Hello friends, welcome to my video. In this video I am going to discuss about the J.J.Thomson experiment which was performed by Sir J.J.Thomson in 1897 to find the specific charge of an electron. So what is specific charge? The specific charge of an electron is simply the ratio of charge to mass of an electron. It is denoted by E by m, where E is the charge of an electron, m is the mass of an electron. The specific charge of an electron is a constant quantity. This experiment is based on the principle that if an electron is subjected to electric and magnetic fields, it experiences forces. But by adjusting magnitude and direction of fields, the net force on the electron is made zero. That is, beam of electrons travel without any deflection. The schematic diagram for J.J.Thomson experiment is shown here. Here we can find a highly evacuated discharge tube. This is the highly evacuated discharge tube. The pressure inside the discharge tube is about 0.01 mm of mercury. Inside this discharge tube, we can find two electrodes. Electrode that is connected to the positive terminal of a high voltage supply is anode, which consists of a fine bore at the center of it along the axis of the discharge tube. There is a cathode connected to the negative terminal of a high voltage supply. So by thermionic process, an electron can be ejected out from the cathode, which is accelerated by the high voltage supply. So this high voltage supply is called accelerating voltage. When an electron is accelerated from cathode to anode, there is gain of kinetic energy. So work done by the electrical force is equal to gain in kinetic energy. Then that electron gets ejected out from the fine bore and it travels in a straight path. The electron strikes on the fluorescent screen at point S when electric field as well as magnetic fields are absent in this region. So in this region, we can find two parallel plates. Upper plate P that is connected to the positive terminal of a supply, and lower plate Q that is connected to the negative terminal of a supply. Because of this voltage, there is the deflection of the charged particle. So this potential difference applied between P and Q is called deflecting voltage. Since electron is negatively charged, this electron will be deflected towards the positive terminal and it strikes on the fluorescent screen at point S2. That is, only if electric field is applied. If electric field is not applied and if only magnetic field is applied, here we can find a magnetic field between plates P and Q, which is directed inward and that is perpendicular to the electric field. If there is magnetic field only, then electron will be deflected towards the spot S1. We can find the magnitude of the Lorentz force as well as we can find the direction of magnetic force using Fleming's left hand rule. So here I have discussed the schematic diagram of a J.J.Thomson experiment. This region is called cross field if electric field and magnetic field are applied mutually perpendicular to each other in such a way that a beam of electron traveling perpendicularly to the fields passes without any deviation. Then that region is called cross field. So let's move to the working procedure. So we came to know that in the absence of cross field, the electrons travel straight and strike the screen at center S. But when magnetic field alone is applied in the region marked as crosses, the electrons are deflected downward and they hit the screen at point S1. The direction of the magnitude of the force is given by Fm equal to BeV sine theta, but theta is 90, so we have Fm equal to Lorentz force or magnetic force Fm equal to BeV, where V is the velocity of fast moving electron. The direction of Lorentz force can be obtained by using a Fleming's left hand rule. Here we find that magnetic field is directed downward, beam of electron is moving from left to right. So using Fleming's left hand rule, we can find the direction of the Lorentz force is downward. Now if electric field is applied between the plates P and Q, then the electron moves in upward direction and strike at S2. The magnitude of the electric force is given by Fe equal to EE, where small e is the charge of an electron and E is the electric field set up across the two plates P and Q. We can write capital E equal to P prime by D, where P prime is the potential difference between plates P and Q and D is the distance between two plates P and Q. So as I already mentioned that when both fields, electric and magnetic fields, are applied in the same region perpendicular to each other in such a way that the beam of electrons entering the region perpendicularly travels without any deviation, then that region is called cross field. So when we apply cross field, then the upward electric force will be balanced by the downward magnetic force, and because of which the net force experienced by the horizontally moving charged particle will be 0. So it again strikes on the point S. At this condition we can find Lorentz force Fm equal to electrical force Fe, or substituting we have BE equal to EE, or velocity of an electron P equal to E by P. Again we know that when an electron is accelerated by a potential difference P, that is the potential difference between anode and cathode, there is gain in energy. Here work is done by the electric force. So work done by electric force is equal to gain in kinetic energy. From work energy theorem, gain in kinetic energy half mv square is equal to work done by the electrical force, that is E times P. Simplifying, we get V equal to root over twice E P by m. Using above equation, we can write root over twice E V by m is equal to E by B, or we get E by m is equal to E square by twice P B square. So knowing the quantities in the right hand side of given equation, that is knowing E, that is the electric field between two plates P and Q, and magnetic field applied in the cross field, and the potential difference of accelerating field, that is the potential difference between cathode and anode, we can easily calculate the specific charge of an electron. J.J.Thomson found that the value of the specific charge of an electron was 1.70 times 10 to the power 11 coulomb per kg. In this video, I have discussed the J.J.Thomson experiment to find the specific charge of an electron. Thank you for watching my video.